It has also featured in IIT. I just want you to help me on this. But given to you that there is a mass, small mass, capital M. And question, Vasudev, it has also featured in IIT. I just want you to help me on this. But given to you that there is a mass, small mass, capital M, and this is 1 meter. There is a pulley, and to this pulley is hung the mass small m. This length from wall measures 2 meters. Okay, these being given to you. Now, you let the system free. When you let the system free, then small m will move up. Capital M, higher on mass. Capital M is 2 kg. Let me mark the masses as well. 2 kg. Small m is 0.5 kg. And this being the pulley. So capital M will move down, it will follow a trajectory, it hits the wall. Somewhere here it make a hit. So it makes a hit somewhere over here. Then what being asked is, what will be the speed with which capital M will hit the wall? You held the system initially by holding small m, then you let go of small m. As a result, capital M will follow a trajectory, hit wall. When it hits the wall, what is speed with which it does so? Think about it. Nothing much. The crux of the matter lies in what you take velocity at the point of hit. That's it.
What do you mean?
As it hits, in which direction is velocity and how is that velocity related to velocity of small m? Or to articulate it better, how is speed of capital M at the time of hit related to speed of small m?
Well, I suppose we do
That
have
is the reason that. Yeah.
a strength relation
Conventions?
between the speed.
Mm-hmm. That is the mood of this question. Nothing much.
Okay, so let's say capital M goes down, but then, oh, right, that's the
Mm-hmm.
problem, isn't it? It doesn't uniformly just descend downwards or towards left, so there'll be two
Mm-hmm.
angles we have to take into account.
It'll hit making an angle 90 degree. We are neglecting dimension of capital M. So when it hits, velocity will be perpendicular to wall. That's for sure.
Yeah, that's right.
Maybe in this direction. So that will velocity. Let's say that velocity is v, and follow. It is bound to follow this track that also is known to you, right?
Yes.
And so it hits with v.
Yeah.
V
Okay.
being associated with capital M. What about small m at that point in time?
Small m must also have the same speed, though. You see.
And sure. Will you reevaluate?
Oh, sorry. Just a second.
Mhm.
It's been a while since I've solved this constraint relation properly.
Mhm.
Okay, we could just split V into its two components, one along the length of the string, the other perpendicular to the length of the string.
Right, right.
The velocity of small m would be the component of V along the length of the string.
That settles, right? Okay, if you're doing it this way, right?
I suppose
So
that
that's
would
it.
be 1
V.
meter that way and 2 meters that way.
Well, theta
That's
then v cos theta. That's it. Right? We can calculate theta, right?
yeah, V cos theta.
Just calculate it. This one. This was one. And there are few in Iridove. If I haven't taken, just will mark you so as to solve this question by multiple dimensions. By multiple dimension, what I mean, when you take different orientation of frame, one frame with this orientation, x to the right, y upward. The other frame with x to the left, y upward. Yet another we can take wherein we have assumed that origin is fixed or here this way. X from here, this is the origin. The third one, let me take another. Okay. This is the origin for the third one and X to the right for this as well. So I have taken 3 frames over here. Question says a certain part of L by 3 rather. L by 3 part of L by 3 part of the total length, 1/3 of the total length, initially being at hung position, rest on the table. When you nudge so that it starts slipping, at that point in time it was in its limiting equilibrium position. When you nudge or shove, it starts sliding. All the work done by friction as the chain slides off the table. All the work done by friction as the chain slides off the table.
Suppose because you got an expression for friction as function of time. No, rather as a function of wait, one second.
Mm-hmm.
Is equal to mu n,
You'll
and
be able to
n
solve
depends on the
that.
fraction
That's
of
certainly
time.
I'm aware of. What I wanted to know of you is how you break f dot dr when you write f dot dr or fs fk dot dr, then how you break them in mod. What will you write for the mod of fk, what will you write for the mod of dr, and what will be the angle taken between f and dr when you change frames. That's important for me to know. So which frame you want to begin with? It's all up to you.
Suppose
Which
it
one you
would
want
be
to begin with?
prudent to number the frames.
Okay, certainly it should be. So let's say this is frame number 1, which has got at this position the origin, where from it begins slipping, right?
Yep.
The edge, the other end of the chain, the shackle. Frame B or frame 2 is the green one, which has got this as the origin. Okay, this one. Can you see this? This
Yes.
one. This one as the origin. The edge of table as the origin. The other frame is frame number 3. This is the frame. This is the only frame which has got to the left. It's X taken positive. So left is positive. Again, the origin happens to be at the edge of the table.
Yep. Okay.
All right.
So
So these
yeah,
are the 3 frames with this. Yeah. Which one you want to begin with?
frame one seems the easiest.
Okay. Frame 1 seems the easiest. We'll be able to get mu value of mu as it is in limiting state. You know how to get value of mu, right?
Yes.
Like we can write mu k into normal, and normal will be lambda 2L by 3 into g, right?
Yes.
And that should be equal to lambda L by 3 into g, right?
Correct.
Which gets us mu s rather, not mu k. Mu s is how much for us is equal to half. And in Eurodove, they have taken mu k equal to mu s. So we can hold this for mu k. Only this for mu k. Let me then ask you a small amount of work done to begin with will be marked as fk dot dr, right? This is how we'll begin with, right?
Yep.
Okay, then you will help me on FK. For that, you'll have to take an intermediate state. So what do you want to be on table? What hanging? Certain part on table, certain hanging, right? Let's say X part is on table. What's it?
Yes.
So X part being on table, we get it as mu K lambda X G, right?
Yep.
Isn't it?
Yep.
Okay, if you wish, you can mark it as mod. Then dr mod and the angle between fk and dr, right?
Yes.
Uh, from what we can guesstimate, x will be positive out here, right?
Yep.
X is increasing. No, x, sorry, x isn't positive because we have taken x on the table, right?
Yes.
So you'll have to help me in marking. What shall I do? Can I remove mod sign from the first one?
Yeah, I believe so. Yeah.
Okay, so mod removed mu k lambda xg. What about dr, Vasudev? What can dr be marked? Let me remind you of dr. Dr is what to us? Dr is dxi cap, dyj cap, dz k cap, right?
Yes. It's
Dz
positive,
k
so
cap
we
and
don't really have
then
to worry.
okay, this will be how much? Dx square under root as y and x in our case being 0. So mod of dx, right? What will be mod of dx here? Positive, negative, if I intend to move modulus sign.
You could just remove it without any repercussions.
Okay, in that case, I'm marking it as dx. Okay, fine, mark dx. What about the angle between friction and dx or dr?
That will
Friction
be
is
negative.
left.
Yeah. So that'll be negative.
There's one case out here, Vasudev. X part was on the table, right? So if x being on table, let me draw the case for you. X was on table. After certain time, what happened to this x? Something less than x will be on the table, right? From here, this length actually would have been, as it began with 12 by 3, so this length will be 12 by 3 minus x, correct?
Yes.
Okay. X is decreasing.
Well,
X
x.
being this, after some time, this x, I presume, should decrease, right?
Yes. Wait. Um, I do not think. Well, we took the parts of the chain remaining on the table to be x, right?
Correct. So that is with time to decrease, right?
Well,
Won't it decrease?
how are we even using frame of reference here? That does not seem to be impacting our calculations in any manner.
I asked you which frame you are to use, and I have to go with the frame that you have chosen.
Yes, I
Now, on
chose
that
frame.
frame, certainly we can work. We can work in any frame,
Yeah, but
not a
that doesn't seem
contention.
to be in any way impacting our calculations. I know in the end everything should turn out to be the same, but I don't see how it is even
Yeah,
impacting it in one
exactly. You'll
dimension.
have to walk me through it. I'm just posing questions to you. I'm not solving this question. You can solve this question certainly.
Yeah.
But if chosen the way that you have suggested, I should get you the correct ones. So the question being, so far as x is concerned, is x positive or negative? As per our frame, it appears to be a positive quantity, right?
Yes, but if whatever frame we choose from 1, 2, or 3, it will still be a positive quantity. It's tied to the table and the chain. How
Hmm.
does it change depending on the frame of reference?
Let's see. Okay, fine. Allow me to take this frame, right? This is y, this is x, okay? X-axis. And then let me say that x part is on table, right? Okay.
Yes.
As it slips, friction will act in this direction nonetheless. Okay. So I write Fk, mod of Fk, mod of dr, and cos of the angle between them, right?
Yes.
Mod of Fk, will be mu k lambda xg, and x is positive, so mod remove, no doubt. Now what about dr over here? Dr is actually minus of dx, right?
No, I don't believe so because we are not
Okay.
measuring distances in the frame of reference. X will always be the length of the chain
Mhm.
left on the table, and lengths are positive.
So are you in odds with this relation that dr mod should be equal to dx mod?
No, that I agree with. I'm just saying X is independent of the frame of reference.
Hmm. So will no no no. dr means change in x, correct? Dr is tantamounting to dx, mod of dx, right?
Yes.
And mod of dx means change in x, right?
Yes.
Change is always final minus initial, right?
Yes.
So if I write final minus initial, I get that quantity as negative, right? Fine.
Yes,
If
x is
you are
wait, one second, one second. So what I'm
stickler
saying
on,
is x is always
let me
decreasing.
move. Okay, I am moving as per you, Vasudev. As your stickler, I'm moving as per you. Mu k lambda xg, and you say that it doesn't matter. So that'll be dx for me, right, Vasudev?
Sure.
As per your comprehension, okay. And the angle between them will be 180-degree, right? Correct?
Yes.
Okay. And as it moves, work done by friction, what was the value of x initially? 12 by 3, right?
Okay, sorry. I might have made a mistake here. What I'm saying is,
And
yes,
then
it
0.
has to be negative. X is decreasing.
Right.
But my
Because
argument
this will
was,
get me work as positive, which is not possible,
yes,
right?
okay, x has to be negative, so uh, dr is minus dx. That's the case
Yeah.
everywhere. That's the case even in the first instance, the one at the bottom
Okay.
left.
Let us
It has
take
to be
one at a
negative.
time. Let us take one at a time. This one will get me the correct answer. So fine, this done. Now let me
Yep.
work on this one, Vasudev. This one, the green one, which I marked 2. Correct?
Would you continue, I mean, working on one? Just for reference. I mean, we're already
This
halfway
one,
through.
this one. What we'll get from here? From here we'll be get. I think this is done, right? Lambda, that you x squared by 2, and then we'll place the value, lower limit, upper limit.
No.
We'll get a negative quantity.
You've replaced dr with positive dx.
Dx, mod of dx.
Yeah, I know.
Dr, I have replaced. Yeah, okay.
But dx is inherently negative here, right? Because x is decreasing.
Correct. So mod of dx, I'll have to write mod of dr as mod of dx from here, right?
Yes.
And as x is decreasing, so dx will be negative, right?
Yep.
So I'll have to replace it by minus of dx, right?
You had it before. One second.
Got it?
Yep. So
And then minus.
if
Got
that's the
it?
case, it'll be minus dx everywhere. How does the frame even
Okay,
interact with
okay.
it?
Let's check. No issues. Let's check this one. The one which is being marked green, frame two, right?
Correct.
Okay. So in frame two, yet again, I write mu k lambda x g with a mod, dr with a mod, and cos of the angle between them, right?
Yes.
Now you can reckon that x here will be negative because my positive x is to the right of the edge, right?
Mm-hmm.
So if x is negative, will I not have to preface it with a negative sign?
No, see,
What's it?
I have
Hmm.
defined x as the length of the chain that's on the table.
Hmm.
In my mind, lengths are
Okay.
always positive, so it shouldn't matter which frame of reference you're talking from.
But what about the frame that you chose, dear?
Yeah, so if
That
you
x part is to the left of the x-axis, right?
no, if you were measuring the position of the leftmost end of the chain, then I would agree with you. But you are
Hmm.
measuring the length, in which case you would have to take the mod of whatever measurement you do
Okay.
anyway.
Suppose I get the coordinate of this point as minus 5, right?
Mm-hmm.
What will you write length then? 5, right?
Yes.
That is what exactly I did over here. My x is negative, right?
Mm-hmm. Yes, I know. So just a second. The only contention I have is, okay, let's
Hmm.
say once you've defined it as x. Okay, in your mind, what is x? How have you defined x?
X is the length, but and that length will be positive as well. That goes without saying. It will depend on my frame, how I have taken, which direction is positive for me. That is what is the limited which I want to raise as a point.
Okay, so if you say that, then my argument is uh,
Hmm.
lambda x should always be the
Hmm.
mass of the chain that's on the table.
Correct.
Right? That's always given by lambda x, no modifications.
Yeah, lambda x, x being negative. That's it. Lambda minus x is what I to say. What am I to say is lambda minus x. You are saying lambda into x is mass. Lambda into minus x is mass.
All right, I just think it's just a different perspective, and end result is always the same.
Oh, yeah,
It's
correct,
considering the
correct.
length.
Let's see, with your perspective, I'll solve with your perspective as well. If you have the match, a ditto on answer, I don't have any objection to it. Neither can anyone object, of course. So dr mod of dx, what about mod of dx, dear? Now what is happening to x? Just think about it from -5 to -4, right?
Yeah,
To -3.
it's increasing like that.
Okay, so that can be marked as dx here, isn't it? Okay. And cos, of course, is -1, right?
Yes.
From where to where, dear? From where to where? X has changed from where to where?
Negative
Minus of
0.
12 by 3.
Yeah, yeah. All
Let
the
me
way
say
to 0.
that.
Yeah.
To 0, right?
Mm-hmm.
Okay. One thing we are sure of, Vasudev, that I should get negative answer because work done by friction will be negative, right?
Yeah, yeah. You should.
Now, let's say what you were professing, I go by whatever you have suggested. So this will become positive according to you, right?
Yeah, so no, I think I understood what I was saying. I have considered, I've defined x as pretty much the length. You have defined x as the coordinate of the leftmost edge from whatever frame of reference you're talking from, and you're deducing the length from that. So I think the end result is
Mhm.
always the same. So
So then let me ask, what about dx in your case or dr mod?
in my case, I've not defined x as a coordinate. I've defined x as the
So
length. So
I got for this case the answer with the negative prephrase, right? I'll be getting this one, right?
yeah,
So where is the argument in your case, whatever you're trying to suggest, where is the exception to this? Exception will be this being positive, right?
yeah.
That's the only one that you have to raise? Is this the only objection, this will be positive?
No, at this point, I have no objections.
So if this is positive, Vasudev, then I'll end up getting a positive answer.
No, I understood it. I do not have any objections at this point.
Okay, so this should be negative, right? This one?
Yes, yes, it should be.
Okay. That's what limited that I have to raise here. And to other questions, there are a few mechanical questions, Vasudev, if you're aware of. Let me mark one to you. This one very mechanical, and we should get to know the end result so as to apply it without of much calculation. They say that there's a force F applied, mass is m, this mass is, let's say, small m. The force applied, what should the minimum value of force, which is when withdrawn, this bounce. Not at that point it'll bounce, but it makes it bounce at some point in time. So these are the ones in Ayurdov, they have gotten you this way, that there is mass which is kept over the other, and this is pulled with the help of a string. So delta L is the length by which it is pulled, so that the spring is in the compression of delta L. What should be the minimum value of delta L? When string cut, small m should bounce. It's a different way of the same. They are trying to draw a narrative over here based on length by which it is compressed, and over here force. Known to you?
Yes, yeah, it is.
How do we go about it?
Um,
Known, right?
yeah, it is. It is known.
Okay,
I
fine.
have to
So
explain
I'll
it
get
further.
you one question. Okay, I'll get you a new question if we have lost on it. If I have not taken work by energy with you, I would have dealt this one. So this is the case given to us, and there is another mass out here. We can neglect dimension of pulley. These are the pulley. This one, this is the pulley, pulley one. This pulley two, we can neglect the dimension. There is a bob over here of mass small m, and there is a bob over here of mass capital M. Length of string being 6L, and it is initially in the form of an equilateral triangle, right?
Okay.
You can mark the points A, B, and C. So AB equal to BC equal to CA equal to twice of L given to you, right?
Yeah.
You release small m. So what should be the value, or what should the ratio of small m to capital M for these masses to cross each other? It's a very good question, a good insight on what we can perceive. Very good insight on what we can perceive vis-a-vis speed. So will they cross each other or not? We have a rider for that as well. Assuming that they are crossing each other, what should be ratio of small m to capital M? It begins with the ask, where will they cross each other? Can you tell me that? That is mathematics. Where will they cross each other?
Oh, the point at which they cross each other.
Yeah. Let's say they are crossing each other over here. They are not to brush each other, they are not to rub each other wrong ways. They're crossing each other, let's say, just passing by. Okay? Not making a pass, passing by. So what is the value of OP? If this is O, then what should the value of OP be asked?
We can calculate that, right? The value of
Yeah.
AP
Mm-hmm.
must be 6L over 4.
Mm-hmm.
So that
So we get a figure of the kind. This way you mean to say like this one. This is what you'll be getting, right? This is let's say this is
one
X.
side
This
would
is
be
X.
3L over
This is
4 and the
12.
other side would be just L, right?
Okay, so 2L, XX, 2X and 4X, right? Should be equal to 6L. This is what you mean, right?
Yes. No. No, that's not what I mean. Uh,
Is not? This will be this way, right? Vasudev when they're crossing.
yeah, so I'm saying 4x should be equal to 6L. 12, this string won't be present at all.
Okay, fine. This will not be present. You're right. So 4X is equal to 6L. And X is equal to accordingly we got. From here we'll be able to figure it out. Okay, got it. Next, what will be the ratio of small m to capital M for this to get actualized? How will you go about that one?
We can we can consider that we already know the
Mhm.
ratio of small m to capital M and try to figure out where the equilibrium position would be.
Which theory you'll implement here? What will you be institutionalizing?
Uh, so yeah, as I said, we'll consider we already know mass of capital M and small m, and then we'll balance all the forces and figure out at what position they would be at equilibrium.
Are you to institutionalize balance force or energy?
Force balance, I think, preferably.
Hmm. So you're of the opinion they are just to cross there, or they'll stop there, right?
Um,
You can. You are going with equality. I may go with greater than. Fine. Whatever. If I am to cut to the chase, ask you when they're crossing each other, if I am to conserve energy, I should know their individual speed, right?
oh no, but maybe I'm wrong about that because if we just consider their equilibrium position, I mean, obviously this will
Mhm.
result in a periodic motion of sorts, right?
Right. Right.
So they will be oscillating about that position. So maybe just considering the equilibrium position will not do us any good. We need to consider all the ranges of positions they go through during the course of that motion.
In that case, energy you will be able to write potential for sure, right? Work
Yes.
done by tension zero, so we can conserve energy. We can write potential in accordance with their position, that is fine. We can take this as reference and accordingly initial position of this being down, so negative, this zero. In kinetic energy, this zero. So what do we get initially as minus of mg and this length om? I'm writing it as om, right? We can figure that out, right?
Yes.
This length om, fine.
Yes.
And they should be equal to us. They when they are crossing each other, this is minus of mg op, right, and minus of mg op again, right?
Yes.
Now plus of half m v small m square plus of half capital M v capital M square. Now this is to me the crux of the matter. What about v capital M v small m? I don't have an equation other than this. I have to relate v capital M to v small m. What say you? What relation they share? OP we know, OM we know.
Hmm.
We don't know small m, capital M. We want to get the ratio. So one equation will do subject to Vm3 small m being related.
I suppose at that point when they cross each other,
Hmm.
it's the situation is very symmetric. So I suppose both of them would, I don't know, have the same velocity.
And what makes you say so?
Um,
Symmetry.
yeah, basically, yeah. I mean,
Okay.
it's a hunch. I'm not very sure that's the case, but it does seem really
You
that
can
that
you
should
can
be
play
the
on your
case.
hunch. You're absolutely right on your hunch. I'm not in any way to deride it. You will have to prove it mathematically. Could you get me a proof for the same? Can you work on tension? Work done by tension. This will move down by d small m. This will move up here by d capital M, right?
Yes.
So you can calculate work done by tension equated to zero. That'll work, right?
Yeah. That should.
Yeah, and from if let's say if capital M is to move up, then work done angle is alpha, right?
Yes.
This angle alpha, we can take alpha, and accordingly, work done by tension on capital M will be 2t cos of the angle alpha, right?
Yeah. Cos alpha
Into
minus.
dm moved upward, and it's the same direction, so positive. On a small m, it will be 2t cos of the angle alpha again, and d small m. I'm taking these to be the length, okay?
Yeah. Okay, I get this. You can cancel those
And
out,
we'll be
differentiate
equated
those.
to zero.
You'll get the velocities.
Yeah,
Okay.
differentiate right here. So we'll be able to prove from there that yeah, dm by dx at that point in time, dm by dt should be equal to d small m by dt, right?
Yep.
Angle being set. So at that point in time, certainly they will have same speed. Once you got that, you'll be able to solve this question. Small m, capital M, we'll get this ratio 2 root 3 minus of root 5 divided by root 5 for them to cross each other. And OP, as you said rightly so, you'll be getting it as root under 5 by 2 into L. Okay?
Just a small doubt here.
Yeah,
Actually,
yeah.
Hercules, how did you deduce that tension is equal to zero work?
Because there's no situation wherein tension is getting slackened. Whenever tension from one state changes to the other state, that is the point where we need to raise our eyebrows. That yeah, there can be work done. By one state to the other means if it is in slack, it changes to taut. If it is in taut, it changes to slack. Only then there is a possibility of there being work done by tension. If through and through it remains taut, then work done by tension is ought to be zero. We are referring to inextensible string, right?
Yeah. Okay.
So total
A
work done
string
by
can't store
tension
any
will be
energy
zero.
itself, and the only energy
Yeah,
it must derive
right.
from whatever it's attached to, the wall or something like that.
Yes.
That's what.
Net work done is zero, not pi parts. In piecemeal, it'll do work certainly, but net work done by tension by string will be zero. Right?
Yeah.
Got it?
Yes.
Okay, dear. I'll keep to this. Right, Vasudev?
Yes, sir. Would you plan on
Take
taking
care,
more
dear. Any
classes?
point? Yeah.
Do inform me at
Uh,
least, like a couple of, I mean, at best a
I
week.
completely positioning to your need, Vasudev. Let you be assured and remove from my end of any doubt. I have banked on your words and I'm still on the same track. Unflinchingly. I know whatever being bygone, let that be where it stands. What you're to get me next is something which is to astound everyone because they may not be known to you. I am aware of you for last 2 years. I've been working, trying to work right.
Yes, sir.
So I have no doubt on your potential. Okay, Vasudev?
Yes, sir.
And same should be the case with you.
Yeah.
Okay? I
Yes, sir.
repose complete faith.
Yeah.
Thank you, dear. Take care.
Have a good day.
Okay, take care. Bye.